today's lesson, we're going to be talking about the rules for line symmetry. If you were to reflect ordered pairs across different types of lines, we're going to talk about the x-axis, y-axis, y equals x, and y equals negative x. Okay? So, on the very first example, you'll notice that we have an ordered pair, point A, which is at 3, 2. Now, if we were to go across the x-axis, does anybody want to locate where that image point would be if we go across the x-axis? That's correct. So we're going to go over here positive 3 units and down negative 2 units. You're going to put a point right here. All right? We're going to call that A prime. So it's positive 3, negative 2. And we call that the image point. Okay? That's the image point. Now, if we have a rule for any point that's reflected across the x-axis, here's going to be the rule that you're going to put in your notes. If you have any ordered pair, we'll call it A, B. You guys notice how the A value, or the x coordinate, right, is the same, correct? That's a 3, that's a 3. What's happened to our y coordinate, though? The A stays the same, but the y became the negative version, or the opposite version of it, all right? So we're going to say AB becomes A negative B. All right? So this right here, I'm going to call this is the rule that you need to understand if you're looking at ordered pairs in a table. Let's say you don't see a graph on a page, but you're looking at ordered pairs. If you see the rule of the x value stays the same and all the y values are opposites of each other, then things are being reflected across the x-axis. All right? Now, let's look at the y-axis. Does anybody want to tell me where the image point would be for this point A, which is at 3, 2? We go across the y-axis. Anybody? You can raise your hand if you want. Go ahead, Tori. Negative 3, positive 2. Very good. So we're going to put it right here. We'll call this A prime. Say negative 3, positive 2. All right, now we're going to talk about what's the rule for all points that are reflected across the y-axis. If we start out at A, comma, B, what has happened from 3, 2? It became what? Negative 3, comma 2. So if we start out at any point, which number stayed the same? Which one stays the same? The A or the B? Which one? The B stays the same. The B stays the same, but what happens to the A? It becomes negative. So this is the rule right here. That's a horrible one. There we go. That's still the bad. There we go. So that's the rule for any point that is reflected across the y-axis. Okay? So if you look at a bunch of ordered pairs in a table, you can figure out, oh, these points are being reflected across the y-axis. If the y value stays the same, but the x values are opposites of each other. Okay? Now, this one's a little bit tricky, all right? So what I want you to do is, if this goes perfectly across y equals x right here, I want you to put the image point right there, because this is perfectly reflected across that. So that A prime would be 2, comma 3. Try to make that better, A prime. All right? So we go down here. Oh, too far. So what's the rule for y equals x? If I have A, comma B, what does that become? Looks like the numbers are, they're switched. BA, because you see how they're switched? So if they're switched, it's not going to be A, comma B, it's B, comma A. You see the pattern there? Now, there's a reason why I used a 3 and a 2 and not a 2 and a 2. And if I would have used 2, 2, if you switch them, it's still 2, 2. It's hard to see the pattern. So if you're looking for a pattern, choose numbers that aren't exactly equal to each other. It makes it easier to see a pattern. Okay? Now this one, this is my A value. If I go perfectly on the opposite side of this, okay? Now, if you're wondering how to do that by hand, let's say some of you like doing art. All right, so make this a little bit less thick. whenever you're reflecting something across something, it's actually going to be a perpendicular. It's going to go through whatever that line is in a 90-degree way. All right, so let me change colors here. So if I'm going to reflect this across, I have to go at a perfect 90-degree angle across it. So let's see here. So it's going to have to be at a 90-degree angle. So let's see if this is 90 degrees right here. All right. Get a protractor. Rotate it here. All right. Do you see how that fits right in there? Okay. So it fits right in there. This distance has to be equal to this distance. All right. So my point, it looks like my point right here is going to be at, that's my A prime. Go ahead, Ryan. -2, -3. Negative B, negative A. Very good. So our A, B, the rule for reflecting across y equals negative x is always going to be, if you start out with A, B, it's going to be negative B. Go a little bit. Negative A. All right? So negative B, negative A. So those are the 4 rules. Okay? I'm only worried about you right now at this point in your life. Reflecting across x-axis, reflecting across the y-axis, reflecting across y equals x, and y equals negative x. So I wanted you guys to have these rules because on problems 5 through 8, it's asking you, okay, after you make a graph and looking at the table, which one of these rules does it follow? Okay, so when you're graphing, so we're going to be working on graphing these today. All right? All right, so on number 5, what we're going to do is we're going to look at this graph, okay? And right now, we really can't graph it. I mean, we could, we did it old school, but we're going to change this to y equals, all right? If we change it to y equals, minus x from both sides, so our equation would be y equals, we'll say, negative x plus 6, or you could say 6 minus x, okay? The points I want you guys to write down on your paper is I want you guys to start at 5, actually, start at 1 and work your way to 5. 1, 2, 3, 4, 5. So I want you to label 1, 2, 3, 4, 5 on your paper. And then we're gonna graph these, okay? All right? So if you think about this, if x is 1, what does y have to be? If x is 1, y has to be 5, yeah, to make it 6. So that's another way, that's kind of like a logic way of graphing it, okay? All right? If x is 2, what would y have to be? 4. If x is 3, y would have to be 3. If x plus y equals 6, all right? We have 4, 2, and then 5, 1. So I want you guys to plot these, okay? So we're going to plot these right here. We have 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. Okay? All right, so I'm going to create my, plot them. Create my line. All right, let's go forever. Now you can look at these ordered pairs, and the reason why I wanted you to write the ordered pairs down is I wanted you to see a pattern. So if I go from, move down just a little bit, if I go from 1, 5, and I also have a 5, 1, which rule does that appear to follow? This is A, comma B. This is B, comma A. So now that you guys have done some notes and you look at your notes, which rule follows A, comma B, B, comma A? And you can see it follows all those. You have 2, 4, and a 4, 2. Y equals X. So this actually, you're correct, is reflected across Y equals X. And you have proof right here in your table. And then what I'd like you to do, so that your brain can kind of see it even better, go ahead and draw a line that perfectly splits so you can see that these ordered pairs are reflected across Y equals x. Okay?
So you want to draw a line to the origin.
So after you determine which one it is, draw that line of symmetry. If you think it's the x-axis, draw the x-axis. If you think it's the y-axis, draw, kind of like highlight the y-axis. If you think it's y equals negative x, do that one. Okay? So what we're going to do right now is I'm going to pause and let you guys try one on your own, see if you can find the rule. All right? Use the graph, and you can also use what? You can use the ordered pairs to figure out which pattern is being demonstrated. All right, so I'll let you guys go ahead and we will. Number 6, just so you guys know, the equation for number 6 is y equals negative x squared plus 2. You have to move that, you have to take this x squared and move it across. Okay, so basically you got to subtract x squared from both sides. No. Don't worry about it. Oh, wait, I'm recording. Oh, I guess I'm recording. No, you can't do that. So, we're going to go and make a table. Let me go to my graphic calculator. I'm going to have y equals, type in negative x squared plus 2. Hit the graph button. Now, when you look at a table, you can only graph certain ones. All right? We're only going to graph, Ryan, these right in here. Okay? Yeah, it is right. All right? So go from negative 2 to positive 2. All right? Negative 2 to positive 2. So negative 2, negative 1, 0, 1, 2. All right? All right, Elise, what are my y values? What for my x value, negative 2, what's my y value? Negative 2. How about negative 1? Okay, 0. Good. 1, and then back to. So these are the points we're going to use. All right, so I want you guys to plot these. Negative 2, negative 2, negative 1, positive 1, 0, 2, 1, 1, 2, negative 2. And if you went 3, what is that? I think it puts it all the way down to like negative 7 or something like that. Yeah. All right. So if we do that, that's gonna put us way down. So right now, just connect the dots. You're making a parabola. It's going up, back down. So what does it look like it's being? What points are being reflected across? If you had to choose one of the 4, which one do you think it best fits?
I think it's across the y-axis.
You're right. It is reflected across the y-axis. Everything's being reflected across this line right here. Now, what's the rule for the y-axis? A comma b. What does that become? What's the negative a b? Well, it looks like you're right. Right here, if we look at these numbers, the y values are staying the same, and the x values are becoming the opposite of each other. Okay? So, for example, one of ours was what? We had a 3 comma negative 7, and I bet there's a negative 3 comma negative 7. Okay? If you scrolled up one more. All right? So that is the correct answer for number 6. All right? The y-axis. So for your answer, you're going to write the y-axis. And you have proof in your table, and you have proof